Welcome back. In lecture 38, we start the hybrid mode choice model. This is the first part of this lecture, and in this particular part, we will focus on the factor analysis. So, the different concepts that would be covered in this particular lecture are on perception and latent variables, factor analysis, exploratory factor analysis, and confirmatory factor analysis. So, before we go into factor analysis, we would first like to talk about the hybrid mode choice model. We call it a hybrid mode choice model because we are using not only need to use not only the standard variables that we have been discussing till now, for example, cost, time, and so on, but lot of variables which are based on human perceptions and maybe based on attitudes or psychological aspects. These are actually ignored. But actually these play a huge amount of role when a person chooses a particular mode. So, when we want to include this kind of models, include this kind of variables in our model, which will actually improve the prediction power of our models, then we also need to understand how to handle this kind of parameters. So, that is why we need to understand certain other things which are not a part of factor analysis, but how to process this kind of data before we actually apply them in the mode choice model. So, that is why we would be learning the factor analysis. So, as you can understand, it itself is a big topic, and within that there are different kinds of factor analysis like exploratory and confirmatory factor analysis. So, we will be touching upon the key points. We won't be able to discuss all the different aspects, and for that you can always study a little bit in details about this kind of factor analysis, but we will cover the points that is relevant for doing a mode choice model and including include factors based on perception data that you have surveyed. So, when we talk about perceptions and latent variables, this latent variable is a term which we will use many times. This indicators could be, there are different people who call latent variables in different names. We will come to that. But perception and latent variables are related, and traditional mode choice models consider only directly measurable attributes to determine the utility of an alternative. But as we understand, the psychological aspects, perceptions, level of satisfactions, these are the things which are very, very important, and that is how people feel about a particular mode actually influences his particular decision. So, that is why we also need to study or understand this particular kind of characteristics of a particular mode in terms of individual's perceptions about that in much more detail. So, there could be several indicators which could measure the psychological aspects, human perceptions, or level of satisfaction by individual, but usually we cannot have many of these factors included in a model. That is why we use something called factors, or these are latent theoretical, we can call them as theoretical latent constructs, which actually incorporate many psychological aspects within each one of them. That means my satisfaction with bus service could be related with my satisfaction with the quality of the service, my satisfaction with safety of the service. Again, quality of service could be again related to the quality of the bus, the quality of cleanliness, and so many other things. So, that means there are several things which actually influences my perception of quality or my perception of safety, but that needs to be asserted. So, this latent constructs could be defined in many ways. Some researchers considered them as hypothetical variables. Some researchers also use definitions where they consider latent variables as things which are impossible to measure, which are unobservable or immeasurable. So, these are the things which are not either observed or cannot be measured, but these are constructs which actually could be measured using other things, but it cannot be directly measured. And the third definition defines latent variables as a data reduction device. That means we have got several parameters, how to reduce those parameters in a meaningful way, so that we can use only a subset of those variables, or and then again combining them subset into a single particular form which could be used in the models. So, this is how people have defined latent constructs. So, in transportation studies, we have seen that different forms of these latent variables are being used, particularly First of all, like there could be situational latent variables like we were discussing. There could be people perceive about safety, comfort, service environment, waiting time, perception about that, how comfortable it was, and conveniences about that particular mode. All these things contribute to the latent constructs related to that particular mode. So these are called situational latent variables, that is people what they feel at that point of time, what is the kind of service they are being provided or the type of alternative that is available to them. So these are situational things, whereas there could be certain things which are based purely on perceptions. For example, we can consider the traveler's attitude, the different subjective norms that he is subjected to, and then the different norms he is subjected to, and then the perceived behavior. That means this comes from the theory of reasoned action. This is a very popular theory used in social science as well as in psychology, where Asjane and Fishbane, they have proposed this theory, where we say that behaviors are a result of behavioral intentions, first of all. And the behavioral intentions are again a function of attitude and subjective norms. Now, attitude means the individual's attitude towards that particular subject, or that, but in our case, that particular alternative maybe. And the subjective norm is perception of general social pressure towards that individual's behavior. That means what society makes him to think about that particular subject. So that means how you are molded and how your attitude is and how the society thinks about a particular alternative, that actually decides how you behave or how you do or how what you decide, right? So that is how this perception related latent variables could be also considered in a model. For example, are you pro-environment or not? Now, are you pro-environment is very difficult to measure, but it could be measured using several parameters. Now, a person who is pro-environment probably is going to choose to cycle instead of taking an auto rickshaw to a particular, maybe a transit station. So these are the things that could be considered while we are developing a mode choice model. So there are perception related variables, and then there are definitely intangible service latent variables. For example, trip fee reasonable. Was the fare reasonable or not? So it is very difficult to measure this kind of variables other than taking some sort of satisfaction ratings for them. So this kind of variables also could be considered. So together they form something called travel intentions. So these are the things which influence our mode choice in addition to the variables such as travel cost, travel time, waiting time, so which are clearly measurable variables. Now, for example, when we have a variable which is like level of transit accessibility, the perception or attitude about that particular thing, it could be measured in many ways. For example, it could be measured using cleanliness of the road leading to that particular stop, condition of the road, condition of waiting area in the bus stop, satisfaction from headway of service, satisfaction from the headway a person that has to wait in a particular bus stop. So all these things may decide his level of transit accessibility, which is a perception related variable. So this could be measured using a Likert scale. Like for example, we take a rating of 1 to 5 or 1 to 7. The 1 is very poor, whereas 5 is very good, something like that. And these are psychometric scales to measure attitude, opinion, perceptions. This we have discussed earlier again in our previous lectures. And satisfaction rating, either we can use them directly in the model. For example, instead of looking into transit accessibility, which is sort of a latent construct, we can say, coming out of all these variables. Instead, we can directly use these variables in our model. But as you can see, there are 5 categories or 7 categories. That means we have to dummy code them with each category taken as either 0 or 1. And so you can understand the number of variables it will introduce in our model. So more number of variables, it becomes difficult to compute those kind of models, and the estimations may not be properly giving good results. The reason is maybe certain things are very loaded towards one parameter and so on and so onwards. So this is one way, or the other way is we need to find the interdependent relationships among variables, and we identify common dimensions or collinear variables or construct called factors. That means variables which are collinear or which are varying together, and they are these could be grouped together, and then they could be made into a sort of constructs which are called factors. And so a wide range of attributes could be grouped into smaller uncorrelated dimensions. So that means within each factor variables are all correlated, but the factors are not correlated within each other. And so this is some form of data reduction technique. So and a factor score can be computed using a linear function using this selected variables to be included in the utility equation. So that means once there are 4 factors which are correlated and they make up one factor, we know that there are these are correlated, so all of them could be combined using a linear equation. That means we have to give some weights to each one of these factors and then multiply with the satisfaction rating that we get for each of these factors, and then we get a score, and that score could be taken as the factor score, which could be directly used in the particular model instead of taking each one of these factors separately. And in this process you will find that some of the factors could be discarded, or some of the variables could be discarded in the process. And there is another technique, of course, to include them in a mode choice model. Instead of choosing all the factors which are related with accessibility, we can choose the topmost factor which is the most contributing to this particular accessibility. And why? Because the other factors we can ignore, because these are highly correlated factors. So either we can take the factor score, or we can take one variable from this particular construct and use it as a representative of all the other variables which are correlated variables in our model, or we can take each one of them individually and check as per the normal ways. We will check their coordinate and all these things later on. So we can include all of them in the model as well using dummy variables and all. So all these ways are possible, and we need to understand which way would be more suitable to us based on the situation on hand. So now, as we have understood, factor analysis is a data reduction technique. It could be a technique to understand the latent construct or the hypothetical constructs and so on. So there are different ways to do factor analysis. So the 2 different ways that usually people use are exploratory factor analysis and confirmatory factor analysis. Now, the first of all, exploratory factor analysis help us to understand the basic factors and the factor loadings or the variables which are loaded to those factors. So using statistical analysis, we can find which are the variables which are likely to form a factor. But this may not actually match with our a priori knowledge. That means we know that there are 4 factors which could lead to a latent construct, but based on the EFA we may find that those 4 factors may not be related. Something else is getting related, whereas one factor is cross loading into another factor, or there could be several factors which are loading into multiple factors. That also could be possible. So exploratory factor analysis is where we explore the relationship, whereas confirmatory factor analysis is where we theorize a relationship and then test if our theory is correct or not. So both of them shows the combined effect of satisfaction variables into, and combine those effects into a particular single factor or a single score. So exploratory factor analysis help us in identifying latent factors underlying a set of observable variables without predecided factor structure, whereas CFA is used to verify predetermined factor structure of a set of observed variables. So this predetermined factor structure is based on theoretical knowledge or a priori knowledge or previous research in this particular area who have identified similar kind of factors, similar kind of variables contributing to a particular factor. So satisfaction rating for bus transit attributes, these are the same variables that we have discussed last time when we had discussed the survey format. We have shown several satisfaction variables to be included in our survey. So these are variables related with satisfaction of bus service, different kinds of bus service, like for example safety, safety from during odd hours, safety from harassment, safety from theft, or it could be related with waiting time, satisfaction with timely arrival of bus stop, satisfaction with expected delay, satisfaction with boarding and alighting time, and so on. So there could be several kinds of factors that could be several kind of perception variables that could be considered in our study, and then we want to do a factor analysis to determine how what are the underlying construct from all these particular variables, or how we can reduce this so many variables into a meaningful number of factors. So, first we will start with exploratory factor analysis. As you can understand, in exploratory factor analysis, we have a list of variables V1, V2, V3, V4 over here, and then these are the factors F1, F2. Each one of these factors has got some role on each one of these variables have some role on each factor. Like for example, this factor is this variable V1 is loaded on the factor by 0.8, and then V2 is loaded onto factor F1 on 0.7, but they are also loaded to F2 as 0.05 and V2 on 0.12. So this is basically correlation is being measured with this particular variable and this particular construct, and or within this particular variables, and then we can see that this two V3 and V4 is primarily loaded into F2, whereas V1 and V2 is primarily loaded into F1. So we can say that these are the factors where these are primarily loaded, but that means but at the same time V1, V2 is also cross loaded to F2 as well. So that is what we can see. Now there are different ways to conduct EFA. So EFA, one main way, one major or one very common way is to do it using principal component analysis. So EFA in our case study, we have also used conducting principal component analysis, and this is a factor extraction method which considers the total variance of that particular data set. And once we have done the basic factor extraction like we see over here, next we perform rotation. There are again different forms of rotation. We have done a varimax rotation. Now rotation, what it does is it changes the orientation of the factors in such a way, it is a theoretical again concept, where we change the orientation of the factors in such a way, because there are different factors and there are different variables. If I consider a 3D space and we point arrows are pointing to the different factors from each variables, if I rotate the factor in such a way so that the loadings become much clearer. That means right now the loadings is on F1, F2, there could be F3, F4. So V1 could be loaded in many. So if I do a rotation in such a way so that we find only specific variables which are linked to specific factors. So in that case, rotation actually increases the clarity of which variables are loaded into which factors. So since factor loading matrices are not unique, that means there are cross loadings, rotation reduces the complexity of the factor loadings and makes the structure simpler to interpret. So that is the purpose of rotation. Then a latent variable or a factor in EFA is identified by the group of variable vectors having loadings more than a cutoff value set by the analyst. So as an analyst, I have to set if the loading is beyond 0.5 or beyond 0.4, or it could be beyond even higher value, which determines which variable is loaded into which factor. That means we will, even though there may be cross loadings in other factor, we will ignore that. So as per the rotation, we will get variables, and as per this particular setting, we will get variables which are loaded into almost a single in a single factor. Cross loadings will be reduced. So in addition to that, we also need to determine how many factors are appropriate for this particular analysis. So number of factors can be determined from the variance explained by the extracted factors, and for this we use something called as Cree plot, where variance explained by each extracted factor is cumulatively added, like we have seen over here, and we see that the variance explained is decreasing, and this is called the elbow point, beyond which it doesn't change much, and we can say that two factors are more than enough to explain most of the variance. So that's why we have chosen two factors. So this is how we determine number of factors which are appropriate. PCA by default, it chooses the same number of factors as the same number of variables. Why? Because each variable is cross loaded into all of the factors, and eventually some of the factors will have very small value, and that could be determined using this Cree plot. For this particular example, which number of factors would be best suited for this particular analysis. So in addition to this rotation method and the type of method to extract the factors, we also have several tests like the Kaiser-Meyer-Olkin test of sampling adequacy. If the number of samples are adequate or not, if it is significant, it's greater than 0.5, then we accept that. Then there is Bartlett's test of sphericity. Again, we check the significance level is greater than 0.5. This actually checks the presence of correlations among the variables. So if there is correlation, then it is fine. Test of internal consistency of these factors, that also we do using Cronbach's alpha and mean intercorrelation values. That is also provided in the softwares that we actually use to do factor analysis. So this is an example of doing exploratory factor analysis using SPSS. So we have the same data view that we have used earlier. All the satisfaction variables are included for different satisfaction. Now we do factor analysis, where we go to analyze, we go to dimension reduction and then factor analysis, EFA, and then we select the different variables for which we are doing this analysis. And then we also describe that, okay, we want to do this Bartlett's test, what are the different tests that we need to do. Extraction method, we give the principal component as the extraction method, we give Scree plots, we want to see that Scree plot and so on. And then rotation, we give Verimax rotation, we can give other rotation as well. And we want to see the rotated solution, we want to also see the factors, and we can also suppress small coefficients to the below 0.4, we can not show them, and then we run the model and then we get the results. So over here we can see the results. So this is the Scree plot, which actually shows us that around 2 factors are more than enough. And then we can see the rotated component matrix. This is the rotated matrix. So there is not too much of cross loading. This is not the rotated matrix. This is the PCA extracted factors. So there is not much, there is cross loading over here, and there after rotation there is not much cross loading. So these variables are loaded into this factor, factor 1, and these variables are loaded into this factor. Now we could also give some, if I look at the variables, these are all related with safety. So that is a latent construct of safety could be determined using this factor, whereas these are based on time performance and then driving characteristics and so on. So this could be based on some other operation characteristics of that transit vehicle. So that is accordingly we can develop these particular factors. So after doing EFA, which actually gives us an idea about how the variables are could be formed into factors, but it may the results may not be matching the theoretical knowledge that we have got, or it may not match the a priori knowledge that we have got. So in confirmatory factor analysis, we actually propose our model that these are the variables which should load into this factor, and then we test if our model is right or not. So this is also called a restricted factor. CFA is also called a restricted factor model. This is because there is no rotation in this CFA. That means we say that these variables are loaded into this factor, and that's a unique solution. There is no cross loading on other factors. So we assume cross loading as 0. Now because we assume cross loading as 0, that means there would be some covariance between the factors. That means some amount of correlation is there between the factors, which is natural. So unlike EFA, we specify the measurement model before analyzing the data. That means we specify the relationship between indicators and the latent variables based on our theoretical knowledge. And this is done based on the theoretical background on how indicators related to the concept. And while indicators are chosen to measure a particular factor, we also could understand which factors are unrelated to which factor. That means we need to understand both what contributes to a factor or which factor contributes to contributed by different variables and which are not. So both has to be understood. And in EFA there are no cross loadings between variables and one factor of one factor with other factor, and that is set as 0. So in the measurement theory, how do we measure the cross loadings? So a latent variable has no inherent metric, and there are 2 ways we can do that. So first, the factor loading of one variable is set as 1, which is the reference item, and other loadings are interpreted in reference to that particular item. This is one way. And the other way is called a standardized solution, where variance of latent variable is constrained to 1, and as per that whatever loadings we get, that would be forming the relationship between the factor and the variables. So, in CFA we construct something called the path diagram. This path diagram shows the indicator which can be grouped together and represented by a latent factor, like this is the path diagram. So, these are the indicators and these are grouped together into this latent factor which we term as bus reliability. So, bus reliability is composed of on-time arrival, boarding alighting time and driving quality. So, this we theorize, and these are the factor loadings, and these are the direction of arrows that you can see. A factor must have more than 2 indicators attached to it, and the direction of arrow from latent variable, which is the ellipse, must be towards the indicator, and this is called a reflective relationship or an indicator. In case of formative indicator, this will be opposite. That means this contribute to this particular factor. So, this we can ignore at this point of time, but we understand that these are the variables which are resulting from this particular construct. And there is another thing, like for each variable, one is the absolute value and then there is the error value. So, both are considered. So, that is actually represented by this rectangle and the E3, this ellipse attached to it. So, this E3 is the error term and this safety from this actually is the actual value that we consider. So, we can understand based on the distribution of this E3 and then we can make certain assumptions as well. So, confirmatory factor analysis is solved using maximum likelihood specification. And then results, what we can do is we can take the results of EFA, which could be the starting model, and then we can gradually remove some variables from the EFA model or add some variables to the EFA model, and then we can also based on the theory we can develop our model, or we can start afresh. That means we propose that these are the variables which are related with these factors, and accordingly we can also develop our model. So, both ways it is possible, and after finalizing the model, we obtain values for each factor corresponding to each response in the data set. So, that means once we formulate the model, then we actually create that, we determine the factor loadings, we estimate those, and that actually helps us to complete our factor analysis. And the validity of the model using several statistics like the chi-square, the goodness of fit index, the aggregate goodness of fit index, comparative fit index, root mean square error of approximation. So, these are sort of R square value, we can say that this is how we measure the fitness of that particular model that we are proposing. Factor scores for each latent variables are calculated using the regression method based on the factor loadings, and the scores are assigned to each respondent for each construct in a manner in which they responded to the attributes that load on each loaded factor in each latent factor. So, if I have individual 1, we have satisfaction rating for 4 variables, so we will have a factor score for this individual by combining those 4 factors or 4 variables and using the factor scores or the factor loadings that we obtain from this particular CFA value. So, we multiply the satisfaction rating of each variable with the factor loading of each variable. The total score is a linear, we can add them using a linear equation, and the total score that we get is the factor score, and that becomes a representative score for this particular aspect for this particular individual. So, that could be used in our modal choice model. So, we usually do that using the data imputation option in factor analysis. So, factors may be also linked to each other to allow them to factors must be linked to each other to allow them to covary. Like this is the factor and this is bus reliability and bus safety are 2 factors, because there is no cross loading in between this factor and the variables for bus safety and vice versa. We allow them to covary. That means there is some amount of correlation that is there, and this is important for model specification perspective, since we do not allow cross loadings of variables between factors, and but we need to be very careful about the high correlation. If it is too high, then we have to reject this particular model, and we can check that using these 2 methods, which is called the construct validity of the model. We can use convergent validity and discriminant validity using these two statistics, we can actually check if this correlation is too high or not. So this could be checked as well, and this convergent validity depends on the factor loadings of each factor and so on. Then once we have done our analysis, we need to check the different statistics, and sometimes there is covariance between error terms, and we can evaluate, we can look into this particular covariances, and then we can improve the model. Or sometimes we at the end of the confirmatory factor analysis, we get this statistics where the modification indices for the model is provided. Looking at that, we can understand that some amount of covariance has to be allowed in between two factors of two variables within a factor, so that we improve the RMSEA value, or we improve the fit statistics. So sometimes that is allowed, but we also have to understand that if these are co-varying, that means it's better to not put them both in the same factor. So that means if this is too much, then we have to actually look into a new factor has to be added into this particular CFA model. That means these two factors are not adequate. We have to add another factor to explain the variance. So that's why this covariance has to be limited. There may not be too much of covariance, but some amount of covariance could be allowed, and we can ignore this kind of covariance as well. So I will show you how to do a CFA, and we have used the software AMOS, which is part of SPSS, to do confirmatory factor analysis. So when we did this, first we did our EFA model, and we have used the base EFA model that we have obtained as a starting point for this CFA. And then based on the statistics that we obtained, because in CFA there is no cross loading, so the factor loadings would be different. And once we obtained the statistics for this particular model, test statistics, we saw that certain variables were not loading properly. We have removed them, and then we are also checking the fit indices, and then we have added some covariances and so on. So to improve the model statistics. So let's look at the execution of this CFA in AMOS. So first we load the SPSS file. So the SPSS file that we have already used earlier, and then we can copy the rotated component metric solution that we obtained earlier, and we can directly place it over here by putting in this pattern matrix model builder. This is a plugin, you can use that. And once we have added that, the same model that was proposed in the earlier EFA is actually brought over here. Then we can modify the model we can modify the drawing. There are some overlaps. As you can see, using these tools, we can modify that using these hand tools. And then we can adjust them using this. See, now everything looks fine. And we can see the error terms are added to each of these variables, and these are the factors. We now give names to the different factors. The first factor is given the title bus safety, because this is related with the different safety variables, and the second parameter is given the name bus operation. This is based on the different on-time performance and so on. Then we calculate the estimates. First we need to save the file. And after that, we calculate the estimates by clicking on this, and then we can see the output. And what are the different parameters we need to see? We can give, like, we want to see standardized estimates. We need to see residual modification indices. We need to see factor scores, correlations of estimates, and so on. And then we look at standardized coefficients, and these are the standardized coefficients that are being obtained. We see one variable doesn't have that value, so we remove that particular variable. That means this variable is not contributing to this particular factor. And after doing that, we again recalculate the model, and this is the factor loadings that we get, which are more or less all near to high factor loadings, but we can also set some criteria to that. And these are the different fit statistics that are given, GFI, and then we can look at this particular statistics and see if all variables, the data that the results are fine or not. And then we come to RMSEA, we can get the RMSEA values. So RMSEA, RMR, all these values are reported. And we also look at the modification indices to improve the model fit. So we can change some of the parameters. So we must make sure that there is no correlation between factors, and here we can add a covariance in between these two variables, and that actually can improve the model a bit. And otherwise, if we feel that this is not theoretically correct, then we can also add another factor as well. So this is how we build our path diagram. This is called the path diagram, and we also estimate the factor loadings in our model. And from this, we have arrived at this particular final path diagram or factor structure, we can also call it. And here we can see the different factor loadings for bus safety and bus reliability. There is a minimum covariance over here, and we can see these two are also correlated, and we can see these are the factor loadings. These are used to compute the factor scores, and that has been that could be done using the data imputation method. So we have two factors, one is bus safety and bus reliability, which can be now directly used in the utility equation. So these are some of the references that you can study. And to conclude, hybrid mode choice models include psychological aspects, service related perception, and other qualitative data, along with directly measurable attributes as explanatory variables. While this psychological aspect, service related perception, etc., could be captured using several indicators which could be directly included in the model, sometimes we need to understand and validate their inclusion by analyzing the hidden constructs behind individual perception and behavior. And finally, factor analysis could be undertaken to both explore this hidden construct in form of latent variables and to also reduce the number of indicators that needs to be included in the model. Thank you.